This meeting is being recorded.
Problem 5 from Chapter 9 asks us to look at these cases below and then determine if the base that's given, the base that's shown, would be sufficiently strong enough to deprotonate a terminal alkyne. So the terminal alkyne that's given below, specifically here. So let's take a look at A, and we can use table 9.2 given below to show specifically which bases. There's 3 listed here in this problem, and we'll look at the table here and see if they are above or below this line here. So this line here, above it, any of these listed bases will deprotonate a terminal alkyne. So we would say yes to that if any of these bases are given. And then below, these bases will not be able to deprotonate a terminal alkyne. And this is based on their conjugate acid strength. So we can see them ranked on the right-hand side with their pKa values given. So let's take a look here. So we know our dividing line, and then those that are listed below will not deprotonate our terminal alkyne. So first we have this base given here in the box in compound with compound a terminal alkyne. So that proton would be able to be removed because this base here is sufficiently strong. And we can take a look at this specific acid would have a pKa approximately 25, and our product would be ammonia, NH3, and the pKa of that is approximately 38. So we can see that given here. So that's another way that we would know that our weaker acid would be favored, and this would cause this deprotonation. All right, so let's look at compound B, and we have this base given here. So that's indicated by this H with a lone pair, and that again would be strong enough. This is sufficiently strong enough to deprotonate a terminal alkyne. So once again, we have a pKa over here, approximately 25 for this terminal alkyne, and then the product would be H2. In this case would be our acid, which has a pKa around 35. Let's take a look at our last example here. So we have our terminal alkyne listed over here, and then we have tert butoxide potassium. So that would result in this base down here, this tert butoxide, and this is our first time that we're going to say no. This is not sufficiently strong enough base to deprotonate a terminal alkyne. It's below that line that we said would tell us if something was able to deprotonate a terminal alkyne. So we know for sure that this would not be strong enough. And in this case, we see that the tert butoxide has a pKa of approximately 18. So this would be the stronger acid, because this, if you recall, has a pKa approximately 25. So these were both yes, and C would be a no.